Okay, welcome to Friday's notes. This is for silver, 1 and 3 on Friday. What is that going to be? The 16th, 17th, 18th of October. This is your 4.1 notes. I am at a math conference, and so I am unable to be with you. So here we go. Looking at the first, so it says we are going to be using formulas to determine terms of a sequence. We want to write an explicit formula for arithmetic sequences. We're going to use that formula to determine unknown terms of a sequence. We're going to determine the next term in a sequence. And we're going to be able to recognize arithmetic sequences and determine the common difference. So here we go. We're going to kind of warm up and build up to it. So as a group, determine the next 3 unknown terms of a sequence and describe the pattern of each sequence. Well, without me being able to be there, we're going to have to kind of do this as we is. So if I look at A and I see negative 35, negative 32, negative 29, negative 26, and negative 23, I want to know what the next 3 terms are. Well, it should be kind of clear that we're reducing this by 3 every single time. So the next 3 terms should be negative 20, negative 17, and negative 14. Well, my pattern for this is, well, I start at negative 35, and that becomes important as we build. So remember, when we look at sequences, we want to know what we start with, okay? And then, what am I doing? Well, I'm adding 3 each time. And how do I know I'm adding? Well, because the negative numbers are getting smaller. Negative 35, negative 32, negative 29. Well, I'm getting bigger, i.e. smaller, by 3 each team, which means I'm adding a positive 3 to it each time. Okay, the next one. Negative 12, negative 3, 6, 15, 24. What is my next 3? Well, they're going to be 33, 42, and 51. Okay? What am I doing there? Well, I started at negative 12, and I'm adding 9 each time. Okay, how about the next one? 3, 11, 19, 27, and 35. Well, if I look at that, I know that I start at 3, right? So, what is my next 3? Well, 3 to 11 is adding by 8. 11 to 19 is adding by 8. So I'm adding 8 each time. And what would be my next 3 terms? They would be 43, 51, and 59. Okay, change colors here. Next one, negative 8, 2, 12, and 22. Okay, well, my next 3 would be 32, 42, 52. What am I doing? Well, I'm adding 10 each time. And where did I start at? I started at negative 8. Okay, and that's going to come into play here soon. So just make sure that you understand that when we look at patterns, not only am I looking at what I'm adding by, but I'm also looking at where I started from. And then last but not least, I'll let you go ahead and do the next one on your own. I'll kind of pause here for a second. And then I want you to look up and see if you're getting the same thing I am. Okay, so E, the next three would have been -4, -8, and -12. Well, I do start at 12, and this time I'm either subtracting by 4, so I'm either subtracting by 4 or adding by -4. And remember, to add by a negative or subtract is the exact same thing. Okay, so each of these are kind of an example of what we call an arithmetic sequence. Okay, and I know you're going to laugh at that word arithmetic. It's not arithmetic, it's arithmetic. And so these are each a kind of an example of an arithmetic sequence. There are more than one kind of sequence. There are geometric sequences as well. We are going to look at arithmetic sequences. An arithmetic sequence is, I'll change colors so we know the difference, a sequence of numbers with a constant / common difference. Okay? It is a sequence of numbers with a constant / common difference. Okay? Common difference and constant are going to be used interchangeably. So, here, common, in this case, equals constant. Okay? They are the same thing when we're talking about sequences. A common difference is a positive or negative number that is added to each term. Okay? It is going to be represented by the variable d. Represented by the variable d. Okay? So common difference is equal to d. Alright. So, now the key part of that is a positive or negative number that is added. So we are looking at addition or subtraction here. Okay? So as I do this, and we move up, the next part says, give the common difference of each of the following arithmetic sequences, then write the next three terms of the sequence. So I look at this and I see 7, 10, 13, and 16. What am I doing? Well, I'm simply adding by 3. So my common difference is d equals 3. D is our common difference. So I'm adding my 3, so my common difference is 3. D equals 3. And what are the next three terms? 19, 22, and 25. Okay, let's look at the next one. -20, -8, 4, and 16. Well, what am I doing there? Well, I'm getting smaller / bigger because my negative numbers are getting smaller. -20 down to 8, and technically they're getting bigger because remember, going towards 0 for negatives is getting bigger. So what am I doing there? Well, I'm adding by, in this case it's 12. I'm getting bigger by 12. So D is equal to 12. And then, what are my next three? Well, they're simply 28, 40, and 52. C, 70, 59, 48, and 37 is my arithmetic sequence. What am I doing there? Well, I'm getting smaller by 11, so I'm subtracting by 11, but we want to use the word add. So therefore, I'm adding by a -11. Okay, and yes, adding and subtracting are basically the same idea in terms of negative numbers, but we want to use the word adding. So, adding by negative 11. So that means D is equal to a negative 11. And what are the next three? Well, the next three would be 26, 15, and 4. Now, letter B says, give the common difference for each arithmetic sequence you looked at in your groups. I.e., we want you to look at what the common difference for all of these A, B, C, D, and E from the first part. I'll give you a moment to go ahead and write what D equals for each of those. Okay? I'll give you a moment, and then I'll put them down. Here we go. D equals 3. D equals 9, D equals 8, D equals 10, and D equals negative 4. That's what you should have got. All right, move to the next page. It says, while a common difference can help you determine the next term in the sequence, can they help you determine the 1,000th term of the sequence? Or how about the 10,000th term? Today, we are going to learn a formula that would allow us to find any term in a sequence without making the problem very tedious. Example number 1. Rico owns a sporting goods store. He has agreed to donate $125 to the Centipede Valley High School baseball team for their equipment fund. In addition, he will donate $18 for every home run the Centipedes hit during the season. The sequence shown represents the possible donations that Rico could make during the season. His first donation is $125. The next, if they hit one home run, would be $143. Okay, so at 125, there are 0 home runs made or hit. 0 home runs. Here there would be 1. Here there would be 2. Here's 3. And here's 4. Okay, so it says identify the sequence type. Well, we're only dealing with one kind, so this is a pretty easy answer. This is an arithmetic sequence. And I know this mainly because it has a common difference. It is going up by $18 each time. It said it in the example, he will donate $18 for every home run hit. So I know this is arithmetic because it has a common difference. And common really is that constant. It's moving up constantly. Okay? Determine the common difference for the sequence. Well, it is D is equal to, you got it, 18. Yeah, because it says he'll donate $18 for every home run. So I know my common difference is 18. So here we go. Letter C. Fill out or complete the table of values for this situation. Go ahead and put me on pause and fill out your table right now. I'm going to go ahead and do it as well. And so we can do this. And as soon as you hit pause, it should be ready to go. All right. Pause me now. Okay, welcome back. You should have this table already filled out. And so you should have exactly what I have. 6 and 215, 7 and 233, 8, 251, 9, 269, and 10 with 287. Now, question for you. Can you determine the 11th term, and how did you find this value? Well, yeah, you can find it. You could continue the pattern, right? I could continue the pattern. And what I mean by that is I could simply add 18 to 287, and then I could add 18 to the number right after that, right? In this case, the 11th term is only going to be one more. So 18 plus 287 is simply 305. I know that. All I had to do was add 18 to 287. Now, is there a way to calculate the 20th term without having to calculate the 19th term? If so, describe the strategy. Well, I'm going to tell you right now the answer is yes. There is a way. And we're going to build the formula. If you've already looked down, you can already see it. But we can do it. What we're going to do is we're going to multiply. Oh my gosh, that's terribly written. Sorry about that. Multiply the common difference by the number of home runs hit at 20th term, and then I'm going to add 125 to it. That is my process. So can I do that? Well, sure. At 20th term, how many home runs did I hit? Well, if I look in my table, that should be pretty easy. If I notice that my turn number is one more than the number of home runs in the table, I have one term number for 0 home runs. I have 6 term number for 5 home runs. I'm at 10 for 9. So I know that I can multiply the common difference, which is 18. So I can take 18 and I can multiply by the number of home runs. Well, how many home runs at the 20th term? 19. And then I could simply add 125 to that, and I could do that math. Well, that comes out to be 467. So I do believe 467 is the amount of money that would be donated at the 20th term or the 19th home run. All right. So what we're going to do is we're going to be able to do a formula for this. Okay? And yes, you're going to have to kind of memorize it or learn it. Okay? And I'm going to erase some of that so I can write in here. So here we go. The first thing, A of n. A of n is what I'm looking for. What I'm looking for, right? That's basically saying like A of n is like equal to y, which is equal to like f of x. Okay? A of n is what I'm looking for. Okay? It's what I'm solving to find. Like in the one problem up here, 467 is what I was looking for. A of 1. Well, A of 1 is my first term in sequence. Remember at the beginning when we looked all the way up here, and I'm going to scroll back up here, and I said the first term in the sequence was going to come back and be important? Like we started at negative 35, we started at negative 12, we started at 3, and we started at negative 8. All of those, we're going to use the first term in the sequence. We're going to use it in our formula. Okay? Now, D is going to be our common difference. We should already know that. So D is our common difference. And N is the term number I'm looking for. Okay? Slightly different than what I'm looking for. It's the term number I'm looking for. Okay? Now, H. Write the explicit formula for the amount of money Rico will donate. Don't forget to simplify the formula. So here we go. Here is the formula. Well, I know that my first term, A1, was equal to 125. Why? Because even if they don't hit a single home run, he was donating $125. I also know my common difference is 18. So I can build this formula right now. A of n is equal to 125, my first term, plus my common difference, times n minus 1. Now it says don't forget to simplify the formula. Well, this is easy. All I got to do is distribute the 18 with n minus 1. So a of n equals 125 plus 18 times n is 18n, and 18 times negative 1 is negative 18. The step that is the most difficult for some of you is this combine like terms. 125 minus 18, not the 18n, but the 18 is 107. So I know that I have 107 plus 18n. And I would rather have it written like this, which is in y equals mx plus b form. Okay? And that kind of tells you this is going to be a linear function, right? But 107 plus 18n or 18n plus 107, I'll take either. Just understand the 18n plus 107 is y equals mx plus b form. Alright, so that's the formula reduced, okay, simplified. Now, you don't always have to reduce it, okay? And we're going to see some examples how you can not do that. Alright, here we go. It says, use the explicit formula to find the amount of money Rico will donate if the Centipedes hit, this time, 35 home runs. So at 35 home runs, what term am I looking for? If you said 36th, you are right. So I know my A1 still is 125. My D is equal to 18 still. We haven't changed the scenario, right? And this time I'm looking for my 36th term because he's hit 35 home runs. But remember, we donated $125 without hitting a single home run. So let's build this formula. A of n, what I'm looking for, 125 plus 18 times n, that is the 36 minus 1, right? So, now what do? A of n equals 125 plus, I can do 18 times 36 minus 1, or 18 times 35. And I can get my 36th term is equal to 755. Easy enough. Now I'm going to do it using my original formula so you can see it both ways. You saw how I plugged 36 in for n and solved down. Now remember, my formula is A of n equals 18n plus 107. That was the simplified formula that we created the original and we simplified it down. Now at 86 home runs, this is my 87th term. So I can plug in, right? I can plug in for this. How many? Well, 18 times, what are we doing? 18 times 87 plus 107. A of n is equal to 1,673. You can see that we can do it either way. Okay? Both examples I did it different ways with the same formula. This one right here is not the simplified version. This one right here I didn't simplify first. I just plugged it in. This one right here, I used the simplified version of it and got to basically the same idea. I was able to get to the correct answers either way for each one of them. Alright, last two examples and you'll be on your own. Okay. It says, example 2, for each of the following arithmetic sequences, identify the first term, a of 1, and common difference, d. Then write the explicit formula. Don't forget to simplify. Lastly, find the 20th term in the sequence. So you're going to see it both ways. I'm going to show you both ways for both. I'm okay either way. Just on your test, if it asks you to simplify once, I need you to simplify it. Okay. So, example A. I have a negative 18 and negative 11 and negative 4 and 3. What is my first term? Well, my first term is negative 18. It's the first term in the sequence. What is my common difference? Well, it's 7. And it's a positive 7 because I'm getting bigger as I go, so I'm adding 7 to it. So what is my explicit formula? Well, that would be A of n equals, my first term is a negative 18 plus my common difference is a 7, and that would be n minus 1. Now, it did say simplify, so I'm going to show you what that looks like. I'm going to simplify this formula, negative 18 plus. And what simplify really means is I'm just going to distribute this 7 with the n, and this 7 with negative 1. So this becomes plus 7n minus 7. I'm simply going to combine like terms. Negative 18 and negative 7. If I owe mom $18 and I borrow another 7, how much do I owe mom? You got it. $25. So that's negative 25 plus 7n. That is the formula simplified. Now, it wants us to find the 20th term. I told you I'm going to do it twice. I'll do it in red once so you see it, and I'll do it in another color the second time. I'm going to start at the beginning, and I'm going to start, the first time I'm going to start right here. The second time, I'm going to start right here. And I want you to see that I will get the same answer. And it'll be color-coded for you so you understand. So here we go, the 20th term. So if I plug it in, A of n equals negative 18 plus 7 times 20 minus 1. A of n equals negative 18 plus 20 minus 1 is 19, so 7 times 19. A of n equals negative 18 plus, what is 7 times 19? 7 times 19. Somebody help me out. Oh, there's nobody here. I can't do that one in my brain. My hamster isn't running fast enough. So 133. Combine like terms and I should get 115. So my answer on the 20th term for this one is 115. Now, let me do it with the simplified formula. So I'm going to go back, and here's the second one, and I'm going to do it in blue, and I'm doing this one. If I'm looking for the 20th term, I could do negative 25 plus 7 times the 20th term, which becomes negative 25 plus, and 7 times 20 is simply 140. And take off 25 of 140, and A of n is equal to 115. You'll notice we come up with the exact same answer. When you're solving these on the test, you can use it from the simplified version or just from the original. I'm okay either way. Alright, last example. Here we go. B. My sequence is 10.5, 5, negative 0.5, and negative 6. Well, my first term is 10.5. What is happening here? Well, I'm getting smaller because 10.5 down to 5, and then down to negative 0.5. So what's happening? Well, I'm getting smaller by 5.5. And it's pretty easy. Just take 10.5, and since I'm getting smaller, I want to subtract and find out from 5, and what is the difference? Well, it's 5.5. So I know I'm getting smaller by 5.5. So now write the explicit formula for it. A of n equals first term 10.5 minus 5.5. Now if you said plus a negative 5.5, it is the same thing. Times n minus 1. It does want you to simplify it, so I will do that. A of n equals 10.5. Now I'm going to distribute the negative 5.5 with n and the negative 5.5 with 1. And that's a negative 1, by the way. So negative 5.5 times n is negative 5.5 n. And negative 5.5 times negative 1 is a positive 5.5. Understand a negative and a negative make a positive. Now, going back, combine like terms. 10.5 and 5.5 become 16 minus 5.5n. Now I would take negative 5.5n plus 16. I would take either one of those. I would be great with the second one, but 16 minus 5.5n would be fine by me as well. Okay. Now, find the 20th term. This time, pick the one that you like the best and go from it. Most of you should probably be more comfortable just plug it into the original equation and not the simplified one. So I will do that because it'll probably be easier for you. So here we go. I want the 20th term. So a of n, which is really the 20th term. And I'm looking for what is my first term? Well, it was 10.5 minus 5.5, and then the 20th, so plug in 20 and subtract 1 from it. So this becomes 10.5 minus 5.5 times 19. Okay? Some of you are going to skip steps and just write 20 inside the parentheses. Remember, it's 20 minus 1 or 19. And then I'm going to multiply that 5.5, and that's negative 5.5 times 19, and that gets me negative 104. So I'm going to have 10.5 minus 104.5. So my a of n is going to have, if I add 10.5 or take 10.5 minus 104.5, I'm going to get a negative 94. Okay? And just so you know that we could have gotten it the same way, if I had plugged it in and gone negative 5.5 times 20 plus 16, you could see that negative 5.5 times 20 would have been negative 110 plus 16, would have gotten me a negative 94 as well. Both ways work. Alright, that's your notes. Your homework will be passed out here in just a moment. Have a great weekend. We'll see you on Tuesday.